Hi class, it's Mrs. Kane and I'm here with your first e-learning video for our next lesson. You just took a quiz on Friday, most of you did, and most of you did really well on that first learning target. So we're going to continue on with Unit 6 and we're going to talk today about simplifying radical expressions, but you're going to notice that instead of square roots, we're going to be dealing with cubed roots, fourth roots, and even fifth roots. So to get started, we're going to go ahead and review how we learned to simplify square roots, and we did that using factoring trees. So the square root of 25. Now most of you can tell me that the square root of 25 is 5. Okay, but I want to use this example just to kind of reiterate what the factoring trees do. So if we were to use a tree to break down the square root of 25, okay, we get 5 times 5. And when we have a pair of numbers, we take that number out, and our answer is 5. Notice in this example, we have no numbers left. Okay, so the reason we use these trees and we circle pairs is because when we have a pair, we're finding the square root. Okay, so when we simplify numbers that are not perfect squares, we are trying to find hidden square roots within the given number. Okay, so the square root of 200, we can do 2 and 100, and then we break the 100 into 10 and 10. And then we circle the tens, and our answer is 10 root 2. Okay, so the pair, that's the number that comes out. The number that's left over goes back under the root. Square root of 12, we can do 3 and 4, and then the 4 becomes 2 times 2. Okay, we circle the pair. We get 2 times the square root of 3. Okay, so that 3 goes back under the root, and the 2 is the one that comes out. Some of you are confusing still which number comes out and which goes back in. So we're looking for pairs. Okay, so I encourage you to stop the video here, go ahead and try the next 3 problems, and then kind of fast forward to check your answers. If you still need a little bit more support, then you can keep the video going while I talk about the you-try problems. So for the square root of 40, I'm going to do 4 and 10, 2 and 2, 2 and 5. Again, I'm looking for a pair. I have a pair of 2's, and this time I have 2 numbers left over. So I'm going to multiply those and put the product back under the root. So I take the 2 out, and then I'm left with the square root of 10. Okay, so the square root of 75. I've got 3 and 25, and then I can do 5 and 5. Take out the 5, and we get 5 root 3. And lastly, for the square root of 18, we can do 2 and 9, 3 and 3. We take the 3 out, and we get 3 root 2. Okay, so most of you should be pretty good or are pretty good at simplifying square roots. So today we're going to extend our knowledge to cubed roots, fourth roots, fifth roots. Okay, and when we simplify using factoring trees, we're using something called the product property of radicals. Okay, so basically it says you can take a square root and you can break it up into a product of its factors. And then if one of those products is a perfect square, we take that number out. Okay, so one thing to understand, a new vocabulary word, is this number here is called the index, okay? And when we take a square root, the index is 2, okay? And square roots are used so commonly that we don't actually put the 2 there. But when you see a square root, okay, I want you to understand that this has an invisible little 2 in the nook. Okay, so if there's no number written there, it's really a 2, and it represents the square root. And that 2 tells us that when we break something down using a tree, we need 2 of a kind in order to take the number out. So today, we're going to use the product property to simplify radicals with higher indexes. Okay, so in this first example, we're going to simplify the cubed root of 27. So we call the index 3. We're going to start the problem the same way. We're going to break this up using a tree. So we have 3 and 9, 3 and 3. Okay, and this time, because we're taking the cubed root, we're actually looking for 3 of a kind instead of 2 of a kind. So in this case, we have 3 3's. And so the cubed root of 27 is 3. And notice that we have No numbers left over, so 27 is a perfect cubed root. Okay, now when we take cubed roots, we can take the cubed root of a negative. If we multiply a negative by itself 3 times, we're going to get a negative. Okay, so if I want to simplify the cubed root of negative 40, I'm going to ignore the negative sign until the end. So I'm just going to use a tree for 40. I'm going to do 4 and 10, 2 and 2, 2 and 5. Okay, but before I circle my 3 of a kind, I'm going to make these 2's negative. Okay, so notice I have 3 negative 2's. Okay, and I have a 5 left over. So if I multiply all of the numbers on the bottom, a negative times a negative times a negative times a positive, I will get negative 40. So the key is when you take the odd root of a negative number, the number that comes out gets the negative sign, and the number that's left over stays positive. Okay, and also make sure that when you write that final answer, you put the original index back in its place. Okay, so if this started as a cubed root, you have to make sure that the leftover number goes back under a cubed root. Okay, if you leave that 3 off, you're going to change it to a square root, and that's not what we want. Okay, let's try another one. So the cubed root of 108. So 108 can be broken into 2 and 54. And then we can do 2 and 27, 3 and 9, 3 and 3. Okay, and the index is 3, so we need 3 of a kind for the number to come out. Okay, so I have 3, 3, so I'm going to take out a 3. And then I have 2 numbers left. I'm going to multiply those, and I'm going to put them back under the cubed root. And so we get 3 times the cubed root of 4. Okay, if you feel pretty comfortable with that, go ahead and try D. If you want to do one more example together, let's go ahead and take a look at the cubed root of negative 54. So again, I encourage you to kind of ignore the negative until the end. So first, we're going to just break down the 54. So we have 2 and 27, 3 and 9, 3 and 3. And again, when you take the odd root of a negative, the number that comes out is the negative one. So notice if I make all of these 3's negative, and I take out a negative 3, I'm left with the cubed root of 2. Okay, and if I multiply all those numbers on the bottom, I have a positive times a negative is a negative, times a negative is a positive, times a negative is a negative. So when I multiply these, I get my negative 54, so I know it works. Okay, all right, so the next set of examples, we're going to take a look at 4th and 5th roots. So again, the key is that the index tells you how many of a kind you need in order to take the number out. So for the 4th root of 162, we're going to do 2 and 81. And again, you can use a calculator if you have a calculator available either on your phone or at home if you're having trouble thinking of these factors. I'm going to do 9 and 9, 3 and 3, 3 and 3. And again, because that index is 4, I need 4 of a kind in order to take the number out. I have a 2 left over, so my answer is going to have a 3 on the outside. Put the 4 back in its place. 4th root of the leftover number is 2. Okay, so again, the importance of that index tells you what you need in order to take a number out. So for 64, we can use 8 and 8, 2 and 4, and then we have 2 and 2, 2 and 2. So we need 4 of a kind, so we've got 4 of a kind right here. We're going to take the 2 out, and then we're left with a 2, so we put the 4th root of 2. Okay, and then the last set of examples, we're going to go ahead and take the 5th root. So this time we need 5 of a kind in order for the number to come out. So if we want to do the 5th root of 96, okay, the first thing we can do is divide that by 2. We get 2 and 48. And then we can do 2 and 24. And then we can do 2 and 12, 2 and 6, 2 and 3. Okay, and so notice right here we've got our 5 of a kind. So we're going to take the 2 out. We need 5 of them because the index is 5. We have a 3 left over. That's going to go back under the 5th root. And so the answer is 2 times the 5th root of 3. Let's move that answer over for you. Okay. So the last example here, we have the 5th root of negative 243. So again, I'm going to ignore the negative. Okay, the number I take out is going to be negative. We can take the 5th root of a negative. So I'm going to do 3 and 81, 9 and 9, 3 and 3, 3 and 3. And I have 1, 2, 3, 4, 5 3s. I'm going to make them all negative. Okay, and when I multiply negative 3 by itself 5 times, I get negative 243. And so when we take the odd root of a negative, the number that comes out is negative. In this case, we have no numbers left over, and so the 5th root of negative 243 is negative 3. Okay, so I would like you to pause the video and go ahead and try the last 3 problems. Okay, and then kind of fast forward to the end so you can check your answers. I'm going to just quickly do the problems, and you can just kind of, I'm going to try and do it quick so that most of you can just do it and check. Okay, so we have 25 and 10, 5 and 5, 5 and 2. 3 5s, and so we take the 5 out and we get the cubed root of 2. Okay, the next one, 4th root of 80, I'm going to do 8 and 10, 2 and 4, 2 and 2, 2 and 5. Only look at the numbers on the bottom. So we have a set of 4 2s, and we have a 5 left over. I'm going to put the 4 back in the nook. So if you got 2 4th root of 5, you're good. And then lastly, I'm going to do 2 and 64. I'm going to ignore that negative till the end. 8 and 8, 2 and 4. I need 5 of a kind, so it's kind of a little tricky to find the ends here. We've got a 2 here, 2 here, 2 here, 2 here, 2 here, 2, and 2. Okay, so I need 5 of them. I'm going to grab 5 of them. I've got 1, 2, 3, 4, 5. Okay, so I'm going to take a 2 out, and then I've got the 5th root of 4. And lastly, we've got a negative sign here, so I actually should have made all those 2's negative. If I multiply negative 2 by itself 5 times, I get a negative, so the 2 that comes out is negative. And so your answer is negative 2 times the 5th root of 4. Okay, I hope these problems made sense. After completing the video, I would like you to complete the short assignment that is in the e-learning assignment folder, and you're going to submit that via Schoology. Thanks a lot, and I'll talk to you tomorrow.